Good day, guys. This is your tutor engineer. Today we'll be doing another installment on financial maths. We already have a couple of sessions here, so be sure to check them out on my channel here on YouTube. So let's start with today's business. Patrick deposited an amount of 18,500 into an account earning R% interest rate per annum, compounded monthly. So as you read the question, it's important to just think about the information that you've been given. So since the deposit was this amount here, this will be our P amount, and then the interest rate is an unknown, so it's compounded monthly. It means in a year you've got 12 months, so our R will be dividing it by 12 because it's a monthly compoundment. And then the question continues to say, after 6 months, his balance was 19,300 rands. So this is going to be the future value, which is going to be our A in this case. So you'll notice that it's 6 months, so that is our N. That's the number of payments. So the payments are happening monthly. The first question is calculate the value of R. Okay, so the formula that is going to be applicable to this situation is this one here. I think you'll remember it well from grade 11. Since you actually use this formula if it's going to be a single deposit that's going to be accumulating over a duration of 6 months in this case. So if it's going to be a monthly deposit, there are other formulas that you're going to use, which I'll be demonstrating later on in the lesson. But for now, this is the most appropriate formula. So let's just plug in all the values that we've been given. Our A, it's 19,319,48. Our P is 18,500. Open bracket 1 plus our I, in this case it's R, divide by 12 since it's compounded monthly, and then we have N, which is 6 months or 6 payments. Now let's just do mathematics from here. So I'll divide both sides by 18,500 since I am solving for R, and then the left hand side will be left only with 1 plus R divided by 12 to the power 6. So with financial maths, so be careful not to install this on the calculator as yet, just wait a little bit longer. So now let's continue on the next step. You still have 193.19,48 on the left hand side, divide by 18,500 on the right hand side. Now we're only left with 1 plus R over 12 to the power 6. So to get rid of this exponent, that will be our next aim. I'll be multiplying both sides by 1 over 6. Sorry, in fact, I'll be raising both sides to the exponent of 1 over 6. So, okay, let me continue from there, right? So, in this case, I can start, okay, not yet really use a calculator. So let's just continue one more step. And then we'll use a calculator so that you don't lose track of our numbers by using a calculator so early. So the left hand side remains with to the exponent of 1 over 6, and then the right hand side, only this part will remain, right? So 6 and 1 over 6 will cancel each other out. Then you'll only have 1 plus R over 12. So you have 1 plus R over 12 on the right hand side. So you can subtract 1 on both sides so that you only have R over 12 on the right hand side. And then you can take it a bit further by multiplying both sides by 12, which I'm going to be doing on this particular step here. That's to the exponent. Okay, so remember this is a 5, so it should be clear. It's 18,500. Everything to the exponent minus to the exponent 1 over 6, then minus 1, and then I'll be having r over 12, and then that's when I can start multiplying by 12 on both sides of the equation, and then I'll calculate for r from here. That's when I can start using a calculator once off. So that's 19,48 divided by 18,500 to the exponent of 1 divided by 6 minus 1 times 12. So that gives me r is equal to 0,087. So if I want to write it in a percentage, I'll multiply by 100, so that would be 8.7%. So that's it for 6.1.1. Now let's go to 6.1.2. Calculate the effective interest rate. So when it comes to the effective interest rate, we first have to understand the formula for it. Now I'll change the color from here to red. So I'll write 6.1.2 over here. So when it comes to the effective interest rate, the formula is I effective is equal to 1 plus I over M. So this is I there. So you can say this is M, and then that's going to be N or M minus 1. So this is going to be the formula. So this is the effective interest rate that we need to work out. We've already worked out the I, which is our R in this case. It's 8.7%. The M is the compounding monthly, and then the effective rate is in this case relevant for the duration of 12 months. So since it's annually, so just consider it annually when you're calculating the effective interest rate. So the next step here would be, okay, let me just say equal to 1 plus the R in terms of decimals. So I'm going to be taking this part, 0.87 divided by the duration of 12 months, right? So that's going to be the duration of 12 months. So in a year, there are also 12 months. So I'll be dividing it. So I'll be raising it to the exponent 1, then minus 1 from the formula. That's equal to, so now let's just put all of that in the calculator. That's 1 plus 0.87 divided by 12 to the exponent 1 minus 1. So that will give me, in fact, wait a minute. This is supposed to be a 12 there. So it's M and M, so it's supposed to be 12, since that's the number of payments. In a year, remember, there are 12 payments. So that should be a 12 there. So if I beg your pardon, so that's 0.08 divided by 12 plus 1 to the exponent 12 minus 1. So that will give us 0.091. So if I want to write this in terms of percentage, that would be 9.1%. That's the effective interest rate. Now let's go on to 6.2. 6.2 says Kuda bought a laptop for 10,000 rands on 31st of January 2019. he will replace it with a new one in 5 years time on the 31st of January 2024. So you notice that 10,000 is going to be the P, because that's the amount that is presently relevant. So the N is 5 years. Since if it's going to be monthly payment, we know that that 5 years we'll have to multiply it by 12 months basically. But now let's read the question. It says the value of the old laptop depreciates annually at a rate of 20% per annum according to the straight line method. So this is a keyword. In other questions, they will ask you about it's going to be a reducing balance. It's not going to be a straight line method sometimes, so just be careful. This is the keyword on this question. I'll talk about it shortly. After how many years will the laptop have a value of 0 rands? So now let me just go back to this straight line method. There's a formula for the straight line method, which is A is equal to P 1 minus N, so the N is in years now, times I. So the straight line method is calculating the depreciation of the laptop every year. So every year is going to be reducing by the same amount, hence it's going to be a straight line method. If it was a reducing balance method, which other questions maybe you'll come across, you would have used this formula here. In fact, that's not going to be a plus, it's always going to be a minus, since it's a depreciation, meaning the value is being reduced. So this would have been the formula if the question was asking us to use a reducing balance method. But today we're going to be using this formula since it's just a straightforward straight line method. So in this case, we need to identify, we've already said that is our P, and then we've got 20%, so 20% is our I, the 5 years is our N. So now we are expecting that in 5 years you're going to have an A, so this A would have reduced to depreciated to 0 rands. So we want to calculate the number of years that is going to be depreciating. So the number of years in this case is not going to be fixed to 5 years. It's actually an unknown basically. So now let's work it out. So the A in this case, we said it's going to be a 0. The P is 10,000. 1 minus the N, that's what we're interested in calculating. And then the I is 20%, so that's going to be 0.2. That's equal to 0. So now, okay, let's just write on this side for the sake of the space. Now you will have, basically we can get rid of this 10,000, right? Since on the right hand side you've got 0. So from here it's just basic mathematics. So if I divide by 10,000 on both sides of the equation, that means I'll be remaining with 1 minus 0.2, N is 0, right? So that's 1 is equal to 0.2 N, then dividing by 0.2 both sides, I'll be remaining with N is equal to, that should be a 5, right? So that's 5 years. That means in exactly this time span here of 5 years, the laptop would have depreciated through a straight line method to 0. So this should be the answer. So I'll just write here 5 years. That's it. Now let's move on to the second question. Kuda will buy a laptop that costs 20,000. In order to cover the cost price, he made his first monthly deposit into a savings account on the 28th of February 2019. He will make his 60th monthly deposit on the 31st of January 2024. the savings account pays interest rate of 8.7% per annum compounded monthly. So once again here, that means we'll be dividing that let's call this 8.7% I. That means we'll be dividing it by 12, since this is going to be a monthly compoundment. Calculate Kuda's monthly deposit into his account. So the deposit is happening monthly, right? And then he will buy a laptop in the future. Look at the waiting for 20,000. So this is going to be our future value at a certain specific period or a certain period of time in future. So the question goes on to speak about there are going to be 60 payments. So this is going to be our N here, since it tells us upfront how many payments there will be. So since the deposit will happen monthly, this is the formula that I was speaking about earlier on. That is going to be applicable to this situation, which is the F is the future value multiplied by the regular payments X, then open the bracket 1 plus I, which is the interest rate, to the power N, the number of payments minus 1, divide by the interest rate. Now we said F is 20,000, so we'll replace it by 20,000, right? And then X is our unknown, right? So those are the monthly deposits or regular payments into the account. So X is unknown in this case, then open the bracket 1 plus I, which is 8.7%. we can convert it to 0.087%, divide by 12, since it's compounded monthly, divide by, there are 60 payments, so N is 60, so everything minus 1, right? Then divide by the interest rate of 0.087, divide by 12, right? So the unknown in this case is X, so we'll just solve for X. So on the left hand side, you've got 20,000. I'll just take this to multiply the 20,000 from this step. So that's 0.087 divided by 12. It's going to be going to the left hand side. Then on the right hand side, it'll only be remaining with X in this case. So including this bracket, since it's multiplying X on the right hand side, on this side it's going to be dividing. That's 1 plus 0.087 divided by 12, everything to the power 60 minus 1. So now let me write X again, once again, on the right hand side. So I'll be putting everything on the left hand side on a calculator, starting with the denominator. Since it's a bit more complicated, that's 0.087 at the bottom, divide by 12, then the plus 1, everything to the power 60 minus 1. Then that's dividing 20,000 on top times 0.087, which is divided by 12. So this gives me X is equal to 267.3 rands. So these are the deposits. These are the monthly deposits into the account in order to achieve the future value of 20,000 rands. I hope that was clear. Now let's go to the final question for today. It says Tino wins a jackpot of 1.6 million, right? So you'll notice that this is the amount that is happening currently. So that's going to be the present amount. He invests all of his winnings in a fund that earns an interest of 11.2% compounded monthly. So here we go again with compounding monthly. So you know that this is an I. This I will be divided by 12 in our formula. He withdraws 20,000 from the fund at the end of each month So these withdrawals, this is X here. That's how much he's withdrawing monthly. And then since you know these withdrawals are happening monthly, this formula should be coming into your mind immediately, which is the present value formula. That's present value is equal to X, which is the monthly payments. Then you open the bracket, then you say 1 minus that's 1 minus, then open the bracket again, 1 plus I to the power minus n, so divided by I. So this is the formula that you must bear in mind reading this question. Okay, let's continue with the question. His first withdrawal is exactly 1 month after the initial investment. How many withdrawals of 20,000, which is our X once again, will Tino be making from this fund? So let's just plug the numbers and just work out the number of withdrawals. So when it speaks about how many withdrawals, we're actually calculating n here. The number of withdrawals is n, so n is our unknown in this case. Now let's put in the numbers first. The present value, it's 1.6 million, right? That's going to be on the left hand side. Then the X, the number of withdrawals, 20,000. Open the brackets. So opening the bracket, you'll have 1 minus 1 plus the I is 11.2%, so we can convert it to 0.112, dividing it by 12 since we're compounding monthly. Then to the exponent minus n, which is the only unknown we need to work out, then close bracket, divide by 0.112, divide by 12. So as you might have noticed or heard or watched my videos before, it becomes uncomfortable to work with big numbers. So you rather want to cancel the where you can, right? So here you've got how many zeros? You've got 4 zeros. And then here, so I'll just trade all these zeros off on both sides of the equation so that I can work with smaller numbers. So you can make less mistakes by working with smaller numbers. So let me continue. So on the left hand side, I'll be remaining with 160. So I'll be multiplying that with this here. That's going to be coming to the multiplying the left hand side. That's 0.112 divided by 12. And then remember this 2 here. It's going to be dividing this side. Then on the right hand side, I'll be remaining with 1 minus 1 plus 0.112 divided by 12 to the exponent minus n. Now I want to get rid of this 1 since I want to solve for n, so I'll subtract minus 1 here, and also on the left hand side I'll subtract minus 1. And then I'll be remaining with 160. That's multiplying 112 over 12 divided by 2 minus 1. Then the left hand side, or the right hand side rather, it's going to be minus 1 plus 0.112 over 12 to the exponent minus n. Now let me just get rid of this minus. I'll multiply all the sides by minus 1 before I can apply a log. So this minus 1 must move to the left hand side. So in this case, the left hand side will change to 1 minus 160. So now it's just basic mathematics now. There's nothing much into this. Just basic mathematics, and then everything will start falling into place. Just need a little bit of patience now since you are working with big numbers or big formulas and big numbers. So now from here, I'll be applying a log, right? So I'll put a log here on both sides of the equation. So in between there's an equal sign. So that means using the log rules, the n, since it's the exponent, it can come in front of a log here. That's going to be 1 plus 0,112 divided by 12. Then the left hand side, you still have log of 1 minus 160, 0,112 over 12, everything divided by 2. So now I'll divide, getting rid of this log here. So I'll divide both sides by it. So including this side by the very same number. Then remember on the right hand side I still have minus n. Now this is when I will start using a calculator. Been patient for this long. Now I'll use my calculator. I'll start with the top, so that's going to be okay, I'll start with 160. 160 minus 0,112 divided by 12, then everything is divided by 2, right? And then 1 minus, and then yes, that's going to be the log. Then I'll divide by the bottom, which is the log of 1 plus 0.112 divided by 12. So that gives me a negative number. That's minus 147,8. That means n is basically 147,8, or we can just say 148. So this will be our answer. So that means there'll be 148 payments. In this case, it's withdrawals, I believe. So let's not say payments, let's say withdrawals. So that's it. I think we've come to the end of the lesson. Thank you for your time. If you like the lesson, please hit the like button. Consider subscribing. Cheers.